So up on the workbench today, we've got this big connecting rod. This is off of our Wallace and Stevens traction engine, and we're in the process of making new bearings. So let's bring you in and have a look at this and see what we got to do. Let's get on. Right, so this here is the big end bearing and connecting rod, like I said, off of our 8 nominal horsepower Wallace and Stevens expansion engine that we're currently doing a motion work overhaul on. As you can see, bearings totally shot, so we're going to be making new. We have made a start on this, so we're going to be getting caught up to where we left off. We made a start on this a couple of years ago now. We had the castings done. That was before I bought a camera for YouTube. So this, like I said, is the connecting rod. So this is your big end. This will big end bearing. This is what gets clamped around the crankshaft, and this will take the rotation of the crankshaft motion and turn it into a linear motion through the slide bars to the piston. So it takes the motion of the piston and turns it into a rotational force. That's what this connecting rod's for. Basically connects the crank to the piston. So it's quite a simple setup. We've got your oiler on the top, bronze bearings, and then you've got your wedges for tightening up the bearing and taking up slack. These bearings can be machined and then scraped in, and you can keep taking them up until they're completely worn out. Well, these ones I'm saying are completely worn out, so we're going to want to make a nice new set for her. So we have already started that, so I'll give you a look at what we got. Right, so here's a look at what we've got. As you can see, there's a bearing shaped piece of bronze already partly machined and roughed in there. Like I said a while ago, we had I made up some patterns and we took them down Bridgeport Foundry, and they made some castings for us. We've done the big end and the main bearings, so they were the bronzes we got done. As you can see, just a split pattern, nothing fancy, just made it out of some scrap wood we had lying about. These obviously are for your cores, these on the outsides. So we sent that down and we come back with some rough castings. So to get you caught up, we put it on the mill and we've machined the faces. Basically this main square, which the bearing's going to be made out of, we've got that machine, got that to size, and got the slots done. And we've done that over on the big Kearney and Trekker. Got no footage of that. That was before I had a camera, so that was done a while ago. But what we have just done is I've took it over to the little chip master behind, and I've squared up this hole, because obviously when you get your when you have a pattern done, you've got your core. So these are your core. I don't know what you call them, spigots or something. But basically, when you pour these bronzes, they will put a sand core in and they will come hollowed out. So that's not very accurate for your hole centre. So what I've gone and done is I've got this hole now, just put it in the chip master and machine that hole true with the centre of this square. I'm not worried about these outside faces, but I wanted that hole in the centre of the mass of the bearing. So that's what we've done. So where are we now? So the next thing I want to do with these bearings, as you can see, they're 2-piece bearings, so I'm going to want to cut this in half now. Somehow get it mounted up in the lathe and bore this to size. So we're going to measure up the crank and accurately bore this to the same as what we got on the engine. So that's the next job. So I'll show you how all this goes together. Got a set screw which bears down on this wedge. So that's undone. So we've got this first wedge that's designed to take up any of the slack in the bearing. And then you've got your second wedge. So they basically, as you can see, just work to take up any slack in the bearing. Obviously you want to scrape that. You can't just wang them up and you expect your bearings to be happy. They heat up and cause all sorts of mayhem. So that's them. And then you've got this strap, which will come off like this. And as you can see, here's the bearing we got to make today. That's simply in 2 halves, fitted into that strap. So this is what we're replicating, and this is what we've got. That's the top, so that should go down in there. That will fit in there, but I don't want to bump it down. I made it a nice tight fit. So we're going to want to mark the centre of this hole, and I think I'm just going to bandsaw it in half. And I figure out how we're going to hold this in the lathe to bore the centre. So that is basically the plan for today. That's got you caught up. Shame I ain't got any of the footage of machining this, but it is pretty much simple, just mill it to size. We've still got a little bit of fettling to do on the outsides. These faces are still up on size, so they just need turning down. So let's get this marked up and go to the bandsaw. First thing I did want to do though is, I'm a little bit worried, being that it's Lauren and everything's a little bit skew-if. I want to check this, what have we got on the table here. Check this connecting rod, see if it's got any bend or twist or bow or dog leg or what have you in it. So I think a simple test for this, it's not going to be a million miles accurate, but it's going to be good enough to get us an idea, is if I lift this end until that end's flat on the table, see that, you could tell when it's square with the table. If we square with the table, and then just get it packed up this end. Right, so that's flat with the table there, and our height stack up. Is that high? So now in theory, if we flip this rod over on this bench, everything being equal, the stack height should be the same. And now you can already see stack height is majorly different. So let's measure that. So that's 7.5 mil. And the new stack height is 14 mil. So we've got a 7 mil bend in our connecting rod, which is fantastic. So that's going to need to be rectified. Seven mil is a fair amount of bend. Looks like it's picked up a bit of a bend on the end here. I don't know whether that was done deliberate when it was put back together with a crank offset, or whether that's happened during use. But she's got a clear kink to her about here, so we need to get a press and press on the end of this rod and get this straightened out best we can. Right, anyway, that'll have to be a job for another day. So let's crack on with our bearing. We'll have to remember that for later future reference. What we're going to want to do is make our bearing so our holes concentric with the sides of these, so that at least we know that our strap in our end is going to line up, and then we'll have to sort this little end out at a later date. So let's get on and mark this up and get them cut. Right, so find the centre of this mass. So I'm just going to touch my right gauge off on there, zero that, so that's 25 mil, that parallel. Take a measurement at the top of the mass, and that is 134 mil, 134 mil. Take 25 mil, and then we want to divide, so that's 109. And then we want to divide that by 2, so that's 54, and then we want to add our 25 back on for the base, so 54 plus 5. So we need 79.5 mil. Should be our center. 79. And then that should provide us a center line. I'll just spin it around so I can see. So that's going to be our split line. Transfer that round to the sides. It's not a million miles accurate, but that's going to be plenty enough to cut that in half. So let's get it over in a bandsaw and slice through it. Right, so we now have 2 bearing halves that should meet perfectly well. Right, so there's our 2 halves. As long as they always go back together the same, once we bore them, we should be fine. So, next thing we want to do is we want to figure out a way to hold these together. I know you can braze them together and do them like that, or you could put them in a forge jaw, but I haven't got a forge jaw that suit these, really, not in the lathe that I want to use. So what I'm thinking the best bet might be is if we load them up as they're going to be when they're in their final resting place. That might need a bit of oil. It's a tight fit, that is. Right, let's keep going. That'll be fine. Oh. That might be a bit tight, you know. It's, it is just that one, so I'm just gonna, of course it's too bloody tight again, so I'm gonna have to get the blue out. Right, fucking just see where this is tight. I want it tight, but we can't be hammering it on. Can't get in the blue now. Ooh. I think this is quite possibly might be the hardest part of the restoration so far, is getting this tin of blue open. I might have the answer. There we go. Just want to see where it's binding. Let's put a bit of this on. Give us an idea of where she's rubbing, and we'll just file a bit off. You see that? See where the blue's been wiped off? Telling me that's high, so we'll file a bit off. Rinse and repeat until it fits. Right, so after bluing and fitting and bluing and fitting, I think we got it now. Put a bit of oil on, make sure we don't get jammed up. Bearing goes on that way. Right, and then this one, line up our marks. That one goes on there like that, and our two split lines should line up. Now the theory is, if I machine them in this block, every time they go back in, seeing as we've got such a nice fit, they should line up perfectly. So we should be able to take this off and put it back on, and it should still be all in alignment. That is the thinking anyway. That's why I want it a nice tight fit with no play. So every time you can take it on and off, on and off, on and off. And it shouldn't be a problem. So the next thing I want to do is figure out how we're going to machine this in this this block without the connecting rod attached, because obviously you've got the block of the connecting rod that comes down on this bearing. But I don't want to spin the connecting rod in the lathe. I could do it in a little Kearns boring mill, but I think she's a bit worn out, a bit tired, so I want to do it in the lathe. I think all we've got to do is come up with some sort of a shim that we can put in between that gap there, and then we can use this taper, make a shim about that big, and then we can just bump it up and pull them bearings together, and then it will be pretty much as it's going to be on the engine, and then we'll worry about clocking this whole assembly up together. That's going to be my plan. So we've got to find a nice wedge or a nice shim to go in there. Sure, we've got a bit of plate round there somewhere. Alright, so find one of these blocks out, go in there, nice. I've also just put a radius in this bottom one to allow for this radius in the bottom of the strap there. I just want to make sure that this face is touching this surface somewhat. So I'm just going to put a big dab of glue on, nice thick. See if we can get a transfer onto that back edge. And we're going to put this in there. Put our key in. See another problem there, look. That key is not parallel with that bearing. Definitely went on that way because there's a witness mark on there and there's a witness mark on there, and that side's got no witness mark, so it definitely went in that way. And it shouldn't matter which way that goes round, but there's a big score mark in the side of that, which I take it's come from that set screw, so it probably went in that way. But if you have a look, there is a distinctive gap this end of the key, or this end of the wedge. So that ain't gonna be no good. That ends 53.3. That ends 53.3. So that means that is parallel. So there's nothing wrong with them. It's going to be in our slots here. They're going to be worn on the inside maybe. Or our bearings are not sitting in there square. I think if we put something in the middle, yeah, look, you see that? That's where it wants to be, and as the clamp goes up, just worn, isn't it? So if I shim, this side. It's my brother's feeler gauges, so don't worry about it. Not breaking my own. Yeah, so that should work like that, I think. So providing that this back face has touched the bottom of this strap, we should be able to get that set up now. There's the result. Blew all the way across there. That'll do. Of course, the first job you've got to do when you use any lathe is change the chuck on it. So we're going to whack this face plate on. Right, so the lathe of choice today is this big old Mastiff. It's a Colchester Mastiff. So I haven't got a forge jaw for this lathe, so we're going to be running the face plate. And we're going to mount our so the plan is to get this mounted up on there, so we can do our turning and our boring operations. So the first thing I'm going to want to do is I'm just going to take a light skim of this and just clean up this face plate, get the rust off of it. Just probably not 100% necessary, but it'd be nicer if we had a nice face on there. So I'm just going to skim that face first. There you go, 15 minutes later. That's going to be perfectly true now. I think it was quite close anyway, but if anything it looks better. Right, next job I want to do, well, next part is I want to get this big bell center in here. So we'll take this monstrous thing out. So the plan is just to hold that in there with the tailstock while we get it fixtured. That should get us somewhere close. So we'll find some clamps and clamp this up against this back plate. So that should get us close to the centre of that hole. And we can check it with the indicator as well. So let's find some clamps. Right, so there's our suitably sketchy for this channel setup. 2 clamps. It's pulled up on that back face, so now we just need to check it for run out and make sure we got this running true best we can, and obviously it's all pitted, so we want our board to be nice and true, 90 degrees against this face. So basically we need to get this running true with the lathe and then do our bore. It's probably overkill for what it is, but so I'm not sure if you can see that indicator. You zoom in. So obviously this ain't going to be perfectly round now that we've done our bandsaw cut. We've closed up 2 faces, so it's going to be oblong. The hole's going to be out of round, so we're going to have to do it 180 degrees out for our indicator. So if you look there by the crack, we're plus 0.5 or 0.05, and we're the same, just a bit over. So that got us pretty close with the center. 30 there. On the other side, we're a bit out, so we want to come. Oh. So 20. I'm just starting to read. So we are 0.4 mil out from side to side. So I'm going to get that indicated up and then we'll start doing our boring. You see what I'm doing there? I'm just going to bump that around. Get that as close as we can get it. Obviously with this pitting in the wear, it's just as close as you can get job really. Right, so I think that's the best we're going to get, so let's chuck a boring bar in it and start taking some cuts. So that's cutting pretty even. Got an even witness mark there and there, so we're pretty close to being lined up. So let's get this trued up. Beautiful finish. It's going to turn out alright. I am fully aware at some point we're going to start running into this back plate, so I've set the DRO. And then when we do, we'll just stay back. And then when we face it off, that last little bit will be gone. Right, so we're just up on the engine. We're just getting a few different measurements on the crank. I'll take this measurement in a couple of places. We haven't had this grind or anything, so I'll get some average measurements and then we'll make it to that. We'll just go around and check it. All the different spots. And what we'll do is we'll take our highest reading and we'll add a bit for oil clearance. And then we'll probably scrape the bearing to fit this journal. Right, so after taking the measurements, this is what we're looking at. This is the sort of shape of our, obviously exaggerated, shape of our crank. This is the highest measurement. This is 86.9. These is all millimeters. So that'd be your 86.9. Our lowest measurements down this side, and then this is quite even. So we've got a deviation in our crank of a measurement of 0.25 mil, which is, we've got 10 thou deviation. According to the book of words, you want to allow for like a 0.1 mil clearance on a 100 mil shaft, which we're at almost 100 mil, so we call it 0.1 mil clearance, which is 4 thou clearance. I think we could probably make that a bit bigger, probably go for double that. We go for 10 thou clearance. So this is a very slow running application. So we got 0.2 mil to play with, and we got 0.25 difference in our measurements. So if I was to make it at the 85, so if we shoot for 8685, that means we're going to be tight on the middle diameter, which is just, it is a small amount of the crank. It's just got a bit of a height difference in the middle. So this is up on size in the middle. So if we shoot it for 85 and then we can scrape out, I'm probably going to regret doing this. Probably should just shoot for that number, but we can scrape out and get our bearing to fit that journal, basically by hand scraping it instead of just turning it. Obviously if this was ground, we could just shoot our number and it'd be perfect, but we're not in the perfect world, and we've just got to make do with what we got. So I think if we shoot for that number there, and then we'll hand scrape the clearance in the middle. So our clearance should be correct. We're going to end up looking like, well, this is obviously exaggerated, but we end up looking like something like that, or actually, so we'll hand scrape the bearing to put a bit of clearance in it, and just make that a nice running fit. It's going to take a lot longer. There's going to be plenty of trips backwards and forwards to the engine to scrape it in, but I think that's what we want to do. So we're going to shoot for 8685, which is 3.419 for inch, people. 1419. Right, now that that's clear as mud, we finished roughing this in now, so we can get a measurement on this. We swapped over to a mic now. So the last thing I want to do before I take it out of the lathe is I'm just going to take a skim cut on this face so that that face is running true with that bore, and then both faces and the bore will be square with the world. Gotta watch, I'm not going to run into that clamp. That's it. And there we go. That bore should be on size. So we can take out of this now. Everything else we're going to do from here on out is going to be done referencing this ID on a mandrel. So we can do our sides and our pressure radiuses all on a mandrel. So that's made a good start on that bearing. That's all I got time for this week. I would like to give a big shout out to the people that's found the Buy Me a Coffee page and made some donations and subscribed, and that's really much appreciated. So as you will know, if you've ever done YouTube, AdSense pretty poor. So we're pretty much just doing this for the love of it. I like making these videos and we like showing what we're doing, so that's what we're doing it for. But the people that do contribute, I'd just like to say thank you. It's much appreciated. And all the money that come in through the Buy Me a Coffee page is going straight back into the content in the products and all the projects we got going on around there. So, like I say, thanks for all the comments as always, and we get you on the next one. Cheers.